Hello viewers, welcome to my channel. Hope you are well. Today we will discuss cyclotron. This machine is used to energize charged particle with high kinetic energy. When a charged particle collides with the nucleus, then it is necessary for nuclear reaction to make such high energy particle. So let us discuss the machine first. This is the physical machine. Now here is the diagram of the machine. These circular dees, semicircular dees, are equispaced and of different radii, within which the charged particle start accelerating. Now it is placed in magnetic field. These are the magnets. This magnetic fields only bends the charged particle to follow the semicircular path, and these semicircular Ds are connected with alternating potential with the oscillator. The electric field here energized the charged particle. Now after each path the velocity increases, thereby increasing kinetic energy of the charged particle, and it is the final kinetic energy before bombardment to a target nucleus. This path is maintained and disciplined by both electric and magnetic field, right? So let us start. This is a top view of the Ds. Clearly you saw these Ds are semicircular and equispaced to allow the charged particle to move through and accelerate within these Ds. Cyclotron is used to bombard nuclei with energetic particles. These particles are charged particles with higher masses. It may be proton or any other deuteron or any other charged ion. But in cyclotron, electron is not used because electron is a very light particle. So it cannot be energized, just like other charged particle, massive charged particle. Okay. Now, when a charged particle moves with velocity v in a magnetic field B, the force is called Lorentz force. This bends the path of the charged particle in the Ds. This is the working diagram. Clearly you see a charged particle from the center first goes to the Ds. This is a positive charge. We say this is a positive charge particle. This may be a proton or a deuteron or a alpha particle maybe. But here first, when D2 is in negative potential, it attracts the charged particle and it enters the Ds, and again it comes, it bends due to the magnetic field. It is placed in this magnetic field. Due to the influence of this magnetic field, the charged particle bend. Now when it crosses to the D1, the oscillating potential inverts. This means this D1 becomes negative and positive. So in this junction the charged particle accelerated and it takes a greater radius to enter again D2. When D2 it comes to D2, again the polarity changes, right? In this process it gradually traverses larger radius and comes to the bombardment chamber to impact the target nucleus, right? This is the function. Now these Ds, an alternating potential is applied between the Ds, right? Whenever this d1 part is positive, it negative, and again it changes when positive, it comes negative, thereby accelerating the charged particle. This alternating potential only accelerates the charged particle. Now, in that radius, the charged particle goes. So, the Lorentz force F equals to Q V cross B, and centripetal force M V square by R. This is the radius R. When these two forces balances, we get the radius of the path, and we find this value R equals to mv by bq, and we can calculate velocity in that radius b q r by m. Now, time taken by the charged particle to traverse the semicircular dees is t equals to, for semicircular, pi r by the velocity v. Okay, so this equals to pi, we put the value of v from the previous equation, m bq by m, and it reads like this: t equals to pi m by bq. Okay, now the oscillation frequency to keep the charged ion in phase is f equals to 1 by t. T is the time period. We have calculated previously that for a semicircular disk, the time taken is pi m by bq. To complete full circular path, the time taken is 2t. So we get bq by 2 pi m. This is the frequency of the oscillating charged particle. This frequency also called cyclotron frequency. Now, kinetic energy of the ion emerging from the cyclotron. We put simply the value of the V here. Kinetic energy half mv square. So, half m bqr by m square. This r is the largest radius of the D before entering into bombardment chamber. So, K is b square r square q square by 2m. With this kinetic energy, the charged particle will collide with the target nucleus to study nuclear reaction. So, this maximum energy depends on the radius r, magnetic field B, and none other things. So, thank you for watching.